a mile below the surface of the Red Sea, is something that, by all measures, shouldn't exist. A phenomenon so strange it is rewriting what we know about the origins of life on Earth, and perhaps even outside of it. In 2020, the Ocean Explorer research ship launched a submersible into the depths of the Red Sea. After 8 hours of scouring the abyssal plain, they had found nothing. Just a lifeless desert in the perpetual darkness. But, moments before they were about to give up and return to the surface, the submersible's headlights caught something in the distance. A murky shape, about 20 meters wide, which looked like a dark mirror laying flat on the seabed. Squinting, they made out what appeared to be a thick fog hanging over it. And as they got closer, they realized that what they were seeing should have been impossible. The surface of that giant mirror wasn't glass or rock or sand. It was water. How could that be? They were already underwater, but it was right there in front of their very eyes, what appeared to be an underwater lake at the bottom of the ocean, encircled by a beach, with gentle, slow-motion waves lapping against the shore. Only a handful of humans have ever seen this sight in person, and we now know something that makes it even more eerie. Any creature who dares to venture below the surface of that strange water never comes back. And yet down here in the deathly darkness, there is something unthinkable. A strange, primitive form of life, existing in a way completely alien to what we ever thought possible on Earth. But now, in 2025, thanks to a series of remarkable discoveries, this surreal underwater environment is helping to revolutionize our understanding of how life can exist on Earth and maybe beyond. So, where did this mysterious underwater lake come from? What could possibly live here? And whatever it is, could it be the key to understanding how life began? I'm James Stewart, and you're watching Astrum Earth. Join me in this video as we journey beneath the surface and come face to face with whatever is hiding down there. Now, I should start off by saying, despite making giant leaps in our understanding of underwater lakes over the last few years, Ocean Explorer was not the first to find one. The earliest reference to an underwater lake dates back to the 1st of March 1964. It's a tiny article, barely taking up a quarter page, buried deep in a scientific journal. The author, a humble English oceanographer named Henry Charnock, had discovered what he referred to as anomalous bottom water 2 kilometers beneath the Red Sea. I like to imagine the sense of wonder, and perhaps even a touch of terror, that Henry experienced when his research suggested the possibility of a lake existing at the ocean's depths. As for what it was or why it existed, he had no idea. All he knew was that it was there, and that it should have been impossible. Without realizing it, Henry had stumbled upon something that would forever shape our understanding of life on our planet. While he could only speculate about the water's origin, Henry noticed one particularly intriguing detail. It was incredibly salty, far saltier than the water above it. This seemingly minor observation gives us the first clue to finding out what these bizarre formations actually are. It seems impossible. How does a lake in the middle of an ocean exist? One thing I'm not salty about is my choice of skincare. We've once again partnered with our friends at Geology to bring you skincare that doesn't just float, it makes waves. If I'm honest, my old skincare routine was pretty washed up, but since using Geology, it's gone from brine to fine. Geology is a 41-time award-winning brand separated from its competitors, like brine separated from seawater. Their salicylic acid face wash, total power wash for your face, washes away impurities like a riptide without leaving you high and dry. Retinol night cream, smooth sailing to reduce wrinkles. And if you're tired of stripping your scalp like a tide pool in low tide, their co-wash keeps your hair anchored and healthy. Take their 60-second quiz today and get a personalized routine shipped and delivered right to your door. And the best part is you can soak up 70% off your personalized trial set. So what are you waiting for? Wade on in. Unlike fish wandering into a brine pool, you'll definitely come back to Geology. See, the more salt dissolves in a volume of water, the more dense it gets. That's why you might be able to float on your back in the sea. but not in a swimming pool. The higher salt content in the seawater makes it more dense, so, relatively speaking, you become less dense and rise to the surface. It's the same with an underwater lake. That incredibly salty water is more dense than the seawater around it, so it sits at the very bottom of the ocean, collecting in the natural depressions on the sea floor. In fact, the water here is so salty and so dense that a submersible literally bounces off the surface like a trampoline. Theoretically, if you were able to breathe and survive the pressure down there, the surface of the lake would feel like a giant waterbed. Scientists call these underwater lakes brine pools, and they can stretch up to 20 kilometers in length, forming majestic lakes, rivers, and even underwater waterfalls. But even more curiously, they can reach hundreds of meters in depth. So you might be wondering, what stops the brine from just spreading out and mixing with the surrounding seawater? How is there such a clear surface line? After all, if you were to add a splash of brine to a glass of fresh water, it wouldn't sink and collect at the bottom of the glass, would it? It would just mix in with the water. So what stops this from happening at the bottom of the ocean? The answer comes down to two distinct natural processes working together in a unique way. The first has the complex name of double diffusive convection, and once again, Henry's observations gave us the first clue of what was happening. That anomalous water, he noticed, wasn't just unusually salty, but unusually warm. So imagine at the very bottom of the sea you have this anomalous water that is both warm and salty. Directly above it you have water that is cooler and less salty. This means that both salt and heat in the bottom water want to spread upwards to the top water. In theory, this should mean that that extra salty water just dissolves away and gets lost in the rest of the ocean. But here's the key thing. Heat spreads 100 times faster than salt, so naturally it gets there first. This means that the water directly above the surface of the lake is warmer than usual, which causes it to rise into the water above. Meanwhile, on the other side, the water directly below the surface of the lake gets cooler, which makes it sink down into the lake. As a result, the top layer of the lake wants to move further down into the lake rather than up out of it. And the seawater directly above it wants to move up and away from the lake rather than down into it. This double diffusive convection is what creates that sharp boundary between brine and seawater, which causes a clear tide line to form, resulting in the surreal appearance of an underwater lake. But if you're especially eagle-eyed, you might have noticed something wrong with that model. Even if there is a clear-cut threshold between brine and regular water, there is still salt going across that line. So, effectively, the lake is constantly losing brine to the water above. In theory, then, the lake should vanish, like a rock pool evaporating over time. And that's where the second natural process comes in. See, underwater lakes aren't just puddles of salty water. They're constantly in flux. Just as brine is continually vanishing into the water above, it's also being replenished from underneath. The lake exists only because of the delicate natural balance between these two opposing processes. The first trying to shrink the lake and the other to grow it. So, where is it being replenished from? What is this seemingly endless source of warm, salty water coming from deep in the earth? You may have heard of plate tectonics, but to answer this question, we need to understand salt tectonics. Scientists scratched their heads for decades, until eventually, the answer began to reveal itself. Across the entire world, we've found brine pools in just 3 places. And these 3 places all have one thing in common, a weird geological feature which allows these pools to form. The first we've mentioned already, the Red Sea. The other 2 are the Gulf of Mexico and the Mediterranean Sea. So what's the underlying feature they have in common? They're all bodies of water that aren't giant oceans. Perhaps they're all partially enclosed? That's part of the answer, but here's the key thing. At some point in their history, all 3 of these water bodies were cut off from the ocean. During the Jurassic period, the Gulf of Mexico was sealed off from the Atlantic Ocean by a narrow strip of land. More than 100 million years later, so was the Mediterranean, and by this point, the Red Sea had also been shut off from the waters of the Indian Ocean. When these seas got closed off from the ocean, they essentially became giant basins. With no new water flowing in, the remaining water in those basins evaporated over time, leaving behind something unusual, a thick residue of salt. Over the following millions of years, that salt residue was buried by layers of sediment, which pushed it deeper and deeper into the earth. So when those dried-up basins eventually rejoined the oceans and filled with seawater again, they created a unique set of geological conditions. Above, you have a sea, and below you have an enormous pile of salt.